Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. The hard part is in this bit here. Okay, do whatever you want. So press pause and have a go. Okay, so to do this, the hard part is this bit here. So rewrite it as this. Hang on. So looking at this, just looking at this bit here, just this bit here, just this bit here. Factor out the n to the power 7. So looking at this bit here, factor out n to the power 7. So if you get this times this, it will then give you n to the power 7. If you get this times this, it will be 5n to the power 7 over n to the power 4, which is 5n to the power 3, which is this bit here. So rewrite this as this. Now, if you look at this, the limit as n tends to infinity, well, when n tends to infinity, this is going to be 0. So you're going to have 1 plus 0, 1 plus 0. So this whole thing here will be 1, will be the number 1. 1 times n to the power of 7, that will be n to the power 7. So it will be this times this, that will then give you this. So as so looking at this bit here, as n heads towards infinity, so hang on, looking at this bit here, hang on, looking at this bit here, looking at this bit here, as n tends to infinity, as n heads towards infinity, this will act as this. The numerator, well, the numerator, this is going to be your dominant term. The numerator will act as this. So as n heads towards infinity, the end behavior will be like this. So now you can tidy this up. Hang on. You can tidy this up. That will then give you this. So now this is a p series where p is less than 1. We know that this series is going to diverge because this is less than 1. So using the limits comparison test, we know nothing about an, but we do know that our bn in this case diverge because this is our an. An, we know nothing about an. This is our an. This is our bn. We do know that our bn will diverge. So we are going to make this comparison. Compare this with this. So this is our bn here. This is our bn. This here is our an. So looking at the limits comparison test, we need to compute this value here. So computing that value, this is our an. This is our an. So it's going to be an divided by bn, but divided by bn is the same as multiplying by the reciprocal of bn, which is this thing here. So this is a reciprocal of bn. So basically we are trying to compute this value here. So computing that value would then, well, this bit here you can rewrite as this. So now and then this times this, that will then give you this. You don't really need to do these two, but times this, that will then give you these two. And then tidy this up. As n heads towards infinity, we know that this is going to be 1. And then as n heads towards infinity, this whole thing here will be this. And then the limit will be 1. So going back to here, we know nothing about our series. We are going to compare it with the series that we know about. We know that our series bn here will diverge. So remember, this is our bn here, this is our bn, this is our an. So we know nothing about our an. We do know that our bn will diverge. We've just computed this. We just computed this and it equals 1. So 1 is bigger than 0. So this is our scenario here. Because we just computed this value and the value here is 1. Well, 1 is not 0, so we can 1 is not 0. So this is out of the question. We just computed this value here. The value equals 1. Well, 1 is not infinity. So we don't need to consider this. We don't need to consider this. We need to consider this. Well, looking at this here, it's saying that these two act in unison with each other. If this converges, this will also converge. If this diverges, this diverge. But we know that our bn here diverge. So therefore, our an, which we know nothing about, must also diverge. So our series here will will diverge. Our series here will diverge just because this thing here diverge. Okay?